Hi guys, in this particular video we're going to look at the characteristic of one of the decay processes, and this is the beta decay. And we had said that the beta decay basically is the emission of an electron, and we're going to of course see later that from the various characteristics that we have looked at in our first video concerning this type of radiation, we said that one of the characteristics is that it's negatively charged, as I've indicated in this specific symbol that I've given preceding this specific name. And then we had said that this is going to be basically can be described as an electron, which is negatively charged. And of course, we had mentioned the concept, and just we're going to give it as is. So we can be able to describe it as an electron which is negatively charged. And we had said that it's going to produce fluorescence, and then it has high penetration powers compared to the alpha particles. And one of the sources that are given for this specific type of radiation is strontium-90, which I've mentioned. Now, apart from that, the beta decay process can be described in the form of an equation, and which we have decided which is going to obey the law of conservation of mass, as I've mentioned for the first case for the alpha particles. Now, in this particular case, we're going to see that a neutron is going to turn into a proton and emit a beta particle, which basically is an electron. And the nuclear changes which are going to be accompanied by this specific type of radioactive decay process is going to, of course, have a difference of the mass number and the atomic number, which are going to be, of course, maintained. And we're going to see that for the general illustration for this one, we can have from a stoichiometric aspect. But as we're going to see from the specific illustration, we're going to give an example of an element that is going to undergo this kind of radiation, and we're going to give thorium-234, of course, which was a product of the first illustration we given for the alpha particles from uranium-238. So therefore, we're going to demonstrate this one using various series that we are going to mention, especially for the uranium series. But in this case, this is going to undergo a beta decay process, and we're going to have this specific product, which is going to be a nuclide, which is having 91. And then this is 234. So there's a change of the atomic number from 90 to 91. And this is going to result in this specific product for the beta -10 given as such. So therefore, if we try to consider the numbers for the mass number and the atomic, which is going to be, of course, give us a stoichiometric form of what are referred to as the loss of conservation of mass, as I mentioned. So in this specific case, then therefore we're going to have this specific example for the beta radiation, and that is going to give us a clue on how this is different from the first one that we had mentioned for the alpha particle respectively. So for the beta radiation, it's going to have a slight variation in a sense that it can be illustrated in two specific aspects. For the beta positive and beta negative, or what we refer to as anti-electron, and the normal beta radiation, which is a beta negative, as I said. So therefore, we can be able to classify this concept of a beta radiation in terms of a beta positive, given as a beta positive and beta negative radiations respectively. So therefore, for the beta positive, this is going to be an anti-electron kind of a decay process, and this is going to be a proton change into a neutron in the nucleus of that specific radioactive isotope. So therefore, we're going to have also this second aspect of having a beta negative, whereby a neutron is going to change into a proton. So therefore, if we are going to try to give this one figuratively, then therefore we're going to have a proton change into a neutron for this beta positive kind of radioactive decay. So next we're going to see the neutron change into a proton, the neutron change into a proton in this beta negative kind of radiation. So therefore this is going to be a reverse process of the first one, and therefore these are unique cases for the beta decay that we're going to see being displayed in this particular aspect. Now, in that specific respect, then therefore we're going to have an illustration in which we can be able to describe this kind of these two types of radiations for the beta decay. And therefore, for the first example, if we try to look at the carbon-14 isotope, it's going to undergo a beta minus kind of a decay, whereby we have said that this is going to result in the formation of a nitrogen-14. The ones that I've given is the mass number which are being illustrated using these numerical values that are following the hyphen that I'm giving. So it's going to be easier for us to understand. So this is going to be followed by this one, and then being illustrated using that particular beta decay process. So the initial that I've given in this specific case for the middle part of this product side is referred to as anti-neutrino, which is another aspect of the radioactive decay process, which we're going to describe later in another video. So this basically is going to be a beta minus type of radioactive decay process. Now, similarly, we can give just a general example for the beta positive. So if I try to change this one just for illustration purposes, so no, this one is just going to be maintained as this for the sake of this description. But let's remember that the above example is for the beta negative kind of radioactive decay. And if we try to illustrate for the beta positive kind of radioactive decay, then we can have an example of this isotope of carbon, which is undergoing that kind of a decay, of course, and we're going to achieve this beta, and of course, what we refer to as a neutrino. So therefore, we're going to have this one, neutrino. So kindly be noting these various symbols that we're going to use. This is a neutrino and this is an anti-neutrino, so we're going to represent them in various equations. So therefore, this is going to result in the formation of what we call a positron as well, which is part of the radioactive product that we're going to encounter. So this one is referred to as a positron, which is basically an electron that is positively charged as illustrated from this specific example. So the beta positive decay process is going to result in the formation of a radioactive or a daughter radioactive product with a neutrino and then a positron given as such, whereas a beta negative is going to result in the formation of a new element, that is N14 for this specific example, and then anti-neutrino, and then an electron which is going to be given as such. So for beta kind of a decay, of course, it's going to display this specific unique characteristic, and of course we're going to discuss of various other aspects insofar as mass is concerned, and other areas. As I've already mentioned, the concept of conservation of mass, the loss of conservation of mass, and other aspects that we're going to see when we're going to do an analysis of various aspects of these decay processes. So catch us in our next videos. We're going to look at another aspect of this radioactive decay process and try to see how we can be able to contrast it from the various other aspects that we have talked, of course, for the alpha and the beta decay processes in this specific respect. Kindly check in our description box for other related video, and subscribe to our channel so that we can be getting updates on various uploads that we do in this specific videos. So that is it for now, guys. Bye. God bless.